as we move into our last chapter that we're going to cover, you'll notice that the schedule actually has us covering 3 sections of chapter 10. And then after the 3 sections of chapter 10, there's some hands-on manipulative stuff that we're going to work with. But I want to say just a couple of words about chapter 10 first. Chapter 10 is the interpretation of graphs section, for better than, I guess it's a better way of saying it than maybe most. So it has been said on many occasions that the numbers don't lie. You've heard that before, right? People manipulate with numbers all the time, and I would contend there's a lot of manipulation with numbers going on with COVID right now. So what we're going to be taking a look at in this section, in some parts anyway, is some of the common misuses of numbers. And what you will see me do, there's not a section, there used to be an actual section that was called abuses of statistics. And when they rewrote the book, they kind of interwove it into the 3 sections instead. And when they interwove it into the 3 sections, it's not quite so blatantly like, hey, look, here's a misuse of statistics. But what you'll see me doing is you'll see me talking about the fact that your graphs, when you create them, have to have these details. Because if they don't, then it could be misinterpreted. If you don't have this kind of a detail, then you're going to end up having the ability to sort of misuse the graph that you're trying to use to persuade somebody in an inappropriate, or at least maybe in a profitable to somebody kind of way. So we're going to start with some basic graphs. 10.2 and 10.3 are actually the funniest sections because they're really just like one giant section that they cut in half. And they didn't even cut it in half evenly. I don't understand exactly why, but just so you know, if you really like mushed 10.2 and 10.3 together, that would actually be one section of material. In fact, you'll even see that the titles say that. 10.2 says displaying data part 1 and 10.3 says displaying data part 2. So they've just divided the material into 2 different sections. So we're starting with part 1, and what we see in these 2 sections is a bunch of different kinds of graphs, and we'll talk about when and how they're best used. So the first graph that we're going to talk about is called a pictograph. A pictograph uses pictures to represent tallies within a category. So my first grader does pictographs at school. So this is something kids do really early on. So we're going to do an example that's maybe not quite so first grade appropriate because it's kind of sad. But we're going to do this example, example 1. The Automobile Club of America considers holiday weekends to start Friday at 6 p.m. and last until Monday at 6 p.m. If 150 people died on such a weekend by 6 p.m. on Saturday, 80 people from 6 p.m. Saturday to 6 p.m. Sunday, and 100 people from 6 p.m. Sunday to 6 p.m. Monday, draw a pictograph of the data. So we're probably not going to present this in first grade, right? It's kind of sad. There's a few things that I'd like you to notice. The first thing I'd like you to notice is, first of all, this is sort of defined in a kind of funny way because of the way it's 6 p.m. to 6 p.m., but it's a real-life situation that it's defined that way, so that's why that's happening. Sort of unfortunate, but still it's appropriate if you think about the car accidents in the way that would make sense, perhaps. The other thing that you might notice is that the numbers are kind of big. Like I can't just draw 150 little stick figures and 80 stick figures and then 100 stick figures. Like we're not going to let whatever shape we choose represent one person. That's not realistic for this problem. So this is how we're going to approach the problem. We are going to make a pictograph, and to start with, let's just draw some horizontal lines. And the horizontal lines are going to be sort of the space holders for my pictographs, pictograph images, and they're going to separate the 3 different, I won't exactly say days of the week, but the 3 different categories of days that are represented in our problem. So on the first one, we might label it something like just Saturday. We understand that it means this sort of a detailed way that they've described it. The next one is up until Sunday, right, from Saturday to Sunday. And the last one's from Sunday to Monday. I didn't mean to do it that way. Hang on. I sort of just wanted them trapped. Of course, that would work. Saturday, Sunday, Monday. Okay. So a couple of possibilities in terms of your images. You'll notice that each of them is divisible by 10. That's pretty nice. So we could just ignore that it says 150 people and have the image in our mind of 15, the image in our mind of 8, and the image in our mind of 10. That's not altogether a bad plan. So if you'd like to use 10 as your sort of scaling factor, you could. So we could use whatever image you kind of want. An image that's complete is, I shouldn't say complete, I'm not exactly sure what word I want, but for example, a circle might be better to use than a rectangle, and the reason is because a rectangle kind of looks a lot alike if I make it half of a rectangle as it does a whole rectangle, and you have to be a little bit more specific. So circles might be nice. I have actually used, when I've done this one in the past, hearts to represent my people as well. That's a kind of nice image because if I had half of a heart, I don't mean like morbidly half of a heart, but like if I drew half the image, it would be clearly half of the image instead of drawing a rectangle as half of an image, and you'd be like, is it a whole rectangle? Did they mean to draw it as a whole rectangle? Were they just being a little bit sloppy? I can't tell. So a heart has a nice imagery to it. So you could let the heart, I'm going to use the heart, represent 10 people. And you have to write whatever it's going to be. Another possibility is you could let the heart represent 20 people. So I kind of like to draw the heart representing 20 people, not because it's preferable, but because there is a place in your book where they do something like that. And I kind of don't want that to be the first time you've seen somebody draw an image where they draw half of an image. So the nicest one from here, well, we'll start with the 80, I guess. We're going to skip the 150 for the moment. The image 80 would be 4 20s, right? So where I have my line or my row for Sunday, I would have 4 hearts. 1, 2, 3, and 4. That would represent 80 people. If you decided to let your heart represent 10 people, you'd need to draw 8 of them. Okay. Nicely enough, on the Monday one is also divisible nicely by 20, so I can make 5 hearts. Be very careful. Your hearts need to line up. So as I'm putting my hearts here, they need to go one underneath each other. What you don't want is something like this. Because at first glance, this looks almost like they're the same number. Okay, I mean, I know we can count them and see that they're not, but it's very confusing visually because one image has bigger hearts and goes further, and that's not what we really mean. So we want to be a little more careful than that, and so we want to line our images up, even if they aren't quite the same size, because, you know, we're not artists maybe, at least I'm not. But it needs to visibly be obvious that the last one is longer than the middle one, okay? The first one is actually 150 people, which does not evenly divide by 20, but the closest value that would be 140. So how many would I get if it were 140? 7 hearts. So we're going to draw 7 whole hearts lined up as well. I'm going to have to draw my lines a little bit longer here in a minute, because actually, let me do it this way. Need a little more space. Okay, and then I need a half of a heart because I'm missing 10 of my people. That's only 140 people represented, so I will draw half of the heart. So literally draw the left half and draw a line straight down, indicating that it's not a whole image. Okay, so let me reiterate a couple of things first, and then a couple of details that we still need to include. First, the things need to line up, right? In this case, my heart images. They need to line up. They need to be roughly the same size. You shouldn't be drawing one image really large and one image really small. So be careful as you're drawing to make sure that they seem reasonable. You need to have a scale. Whatever scale it is you pick needs to match whatever your images are to make sense of the data. But you need to have the scale, and it needs to be written down. So if you chose the heart equals 10 people, that's fine. Just make sure it's included to say that. Okay, the one missing detail that I still need here is I need a title for my graph. Every graph should have a title. And it just needs to describe what in the world this is. You can put the title at the top, you can put it at the bottom, you can put it outside. I don't care where you put it. It just needs to be included. So the title here might say something like Deaths on a Holiday Weekend. Okay, that's a pictograph. all right? All right, very similar to a pictograph is the next one. It's called a dot or a line plot. My 6th graders have been working on this year, and I think that still means that they're actually working on 5th grade math, because I think they're still probably reviewing at this point. That most of the first 9 weeks of a new class is spent reviewing. Did you guys know that? That's not a college thing. That's a K-12 kind of issue of reviewing, especially reviewing a lot of things since we didn't really finish last semester, right? So I think they're still doing 5th grade math. So this might be something that would show up somewhere in 5th grade, okay? So here's what this looks like. It's a quick way to display data with fewer than 50 values. So my kids usually bring it home and they've got, like 10 values or something like that. We're going to do one that's a little bit thicker than that, a few more values than that. And here's our example. This is the mass in kilograms of each child in Mrs. Good's class. So these are different weights of children, and it wants us to make a dot plot. So the way we start with a dot plot is that we're going to draw a horizontal line, and we need to have sort of hash marks representing the data that we have, and we need to make sure it's, again, evenly spaced, that it includes all my data points and the missing data, which means what I need to do is I need to look back at the data points and decide what's the smallest data point, what's the largest. So looking at the data, which number do you see as the smallest? What was it? 39. Okay, and what's our largest value here? I think so, 39 and 49. So we're going to start our line plot or our dot plot with 39. And this is not spanning a very big set. So if it were a lot of numbers, like if we went from 0 to 100, we don't need to make 100 hash marks. We might make a hash mark every 5 or something like that. But this is not spanning a lot of data values. So we're going to make a hash mark for every single one. And they need to be, like I said, pretty evenly spaced apart. You don't necessarily have to label them all, but you might want to because we have a lot of data values that we're going to be placing on there eventually. So I have 42, 43, 44, 45, 46, 47, and 48. Now, I might mention what my kids are actually using this for. They're not actually using it for whole number data like this. They're actually using it for measuring sort of the space or the value size of decimals. That's what they've been using for, decimals and or fractions. So they've been partitioning out a number line for fractions or partitioning out number 9 for decimals to try to figure out how things are being grouped. That's what they've been using it for. So it has lots of uses. What we're going to do is we're going to take the data and we'll just go in order from top to bottom, left to right. And we're going to make a small x on the vertical location of each value. So for example, number 40, and we're going to put an x right here. Okay? We did that one. And we're going to do 42, and we're going to do an x about the same height as the same one that we did before, about the same size on the 42 location. We're going to keep going. 49 and 41 are next. So 49. Oops, I didn't get my 49 on there. Sorry, I stopped one too soon. 49 and 41. 43 and 42. So 43. Now 42 is duplicated, so we stack them, one on top of each other. 48 and 39. 48, 39, 46 and 41. Okay, so I'm going to continue here in just a second, but let me pause for a moment to just remind you that you want to be careful the size and sort of the location in terms of how far up or down your values go. My son has a habit of making things get larger or smaller when he writes them. So he very well might look at this 42 now and say, here, and he might make it extra big. Or he might skip extra space and put it up here because he's not being careful. So I know you guys can be careful, but be aware. The reason it matters is because we want to be able to do when we look at this is to be able to say, hey, look, the majority of them are at this height. I don't have to count anything. I can visually just look at it at a glance and know most of the data values are in this area or at this specific number. Okay, so let's put all of our data values in then. I have 42 and 40. $49 and 45. 39 and 43. 47 and 44, 49 and 42. So one word of caution, there's absolutely no reason to expect that I would have an X in every single number. It just happened here. I made this data up, right? Like I just totally made it up. But you could either make data up that doesn't do this, or you could actually have data that simply doesn't do this. There's no reason to expect that you'd have a value, an X value in each of those columns. You can see here too some things at a glance, right? The whole point in creating one of these is to see at a glance what's happening. You can see that the majority of the kids are in that 39 to 43 range, right? Not all, but the majority. I mean, like it's definitely bottom heavy on this graph. There are more X's on the bottom half-ish of the graph than on the top half. You can also see that the majority, not the majority, but the biggest, that's not the word I want either. The most common weight, we'll go with that. The most common weight is 42 kilograms, right? That's what you can see here. And the second most common is actually 49. So there is some sort of like outliers and some sort of values that are higher than others here, but there's not a lot of them, but they do bunch up a little bit there on the 49. All right, the last thing that we need here is that we need to actually have a data or a title, that's the word I wanted, a title for my graph. Again, you can put it above it, you can put it below it. I have some space here on my screen, so I'm gonna write mine here. This is the mass. You do definitely need to say in kilograms of children in Mrs. Good's class. Fun fact, Mrs. Good's actually a real teacher that one of my kids had. It's a great name, isn't it? So this is a dot or line plot. Notice there's no dots. There's little X's. I don't know why the name necessarily, but that's what it's called. All right, let's try another one. Stem and leaf plots are really cool. Stem and leaf plots, I don't know, they sort of resonate with me because they do really nice things when you're calculating and you're trying to look at the span of grades. So, oops, I didn't mean to do that. These are akin, they're alike or likened to a dot plot, but they're drawn vertically instead of horizontally. The numbers on the left are called stems and the numbers on the right are called leaves. So we're going to look at some actual data. This is actual data from the very first time I taught this class, which looked very different than we teach it now, by the way. But these were actually our exam 1 scores from that particular class that semester, which is like, I don't know, 9 years ago or something, 8 years ago. I don't know. It's forever ago. So the way that you do stems and leaves is that you actually make a horizontal or a vertical line. The numbers on the left are the tens digits, and the numbers on the right are the ones digits. Okay, that's how it separates. These are 2-digit number kind of things. If you happen to have, say, a score of like a 100, you could do the 2 digits for the 10 at the beginning on the left and the 0 on the right. We can do that most of the time. Don't need to worry about it, but you could. What we need to know, again, kind of like we did before, is the largest and smallest data value that you see present here. So what's my largest? What's my smallest? Somebody tell me something. 94 and 43. Okay, so we're going to start our data with the number 40. So we're going to start with a 4. So we have the 40s, we have the 50s, we have the 60s, the 70s, the 80s, and I'm running out of space, so let me shift this up a little bit and we'll make the 90s. And the 90s. Okay, so far so good? And what we're going to do, kind of like what we did over here where we were stacking up the X's, is we're going to write down the values. But we're going to actually write the values because I don't actually just all have the number that's the same. They're sort of grouping them. They're grouping them by the tens digit. So for example, when I see my 87 here, in the 80s column, I'm going to write a 7. And I see my 76 in the 70s, not column, but row, I'm going to write a 6. So that's number 76. I have 94 and 58. So 94 goes in the 4 goes in beside the 9, and 48, the 8 goes beside the 4. Oh, 58, sorry. Too much zooming in and out. 82 and 43. So I put the number 2 beside the 7. That's still 82. And then 43, put the 3 beside the 4. 89 and 53, so 89 goes here, 53 is here. Don't need to worry right now about lining things up or making them look pretty because this is not going to be our final graph anyway. This is sort of an intermediate step. I don't want to say it's absolutely not necessary, but I still think it's way easier to do this than to try to jump to the final graph and make sure all the details are the way you want them to. You'll see why maybe in a minute. 67 and 80, so 67, 80, 94, 90, 94 and 90, 74 and 77, 87 and 74, 89 and 90. Okay, everybody good so far? Already you can tell just by looking at this that there's more scores in the 80s than anything else, right? You can definitely tell that most of the students passed, got a 70 or up. That's good to know, just looking at that data right there. But what we're going to do for our final version of this is that we're going to redraw it, and we're going to put all of the leaves in order. Okay, my stems are already in order. That's how I created it. I've got 4 through 9. And now we're going to put our leaves in order. Well, there's no ordering for my 40s because there's only one 40. It's 43. There's no reason I made this a little bit smaller. It's just what happened on my screen, by the way. So 50s, I have an 8 and a 3, but the 3 comes before the 8, so we're going to put them in that order. Now we are, this time when we're drawing it, going to make sure that each of the numbers lines up with the numbers on top and bottom, right? We don't want to squish them together kind of like I did that hearts on the pictograph to sort of make something look like it's happening that's not happening. So there's 38, I'm sorry, the 3 and then the 8. I only have one in 60s column, that's 67. In the 70s, I have 2 4s and then a 6 and a 7. So I'm going to write 4, 4, 6, 7. In the 80s, I have 0 and then 2. And then I have 2 7s and 2 9s. So 7, 7, 9, 9. And then my last one, I have 2 zeros. My 90s row, I have 2 zeros and I have 2 4s. So one of the things that a stem and leaf plot allows us to do really nicely is it allows us to find the middle value if I've put them all in order. We'll be doing that in section 10.4. So I know that's not happening today, but that middle value has a name. It's called the median. And you can sort of count from the top down and from the bottom up to find what that middle value is very nicely if you've drawn this in here. You can actually also see percentiles, which we'll talk about in section 10.4 as well, pretty nicely here. But visually, again, you can see all of the data values. And they're all sort of in this condensed or collapsed version. It's a lot easier to look at that than it is to look at the original data and make any sort of conversation making sense about that original data. If I look at that original data, I mean, I don't know. Am I drawn to the 43? Am I drawn to the fact that there's several 80s? Am I drawn to the fact that there's a lot of, there's still several people who didn't pass? I don't know. It's not near as easy to sort of make a generalized statement about it as it is when I put it in a stem and leaf plot. There's 2 things that a stem and leaf plot still needs. One thing that it needs is it needs a key, kind of like that scaling key that we did with our heart. We need to make sure that we understand that when we have, I'll just use the first one, it doesn't matter which one you use, 4/3, it means a score of 43, right? We need that on there. So that's my scaling details, something about the sort of a key or a legend. And then we also need a title, always. So this title is grades. So this is grades from a first exam. That's as much detail as it says right now. You know more because I told you, but it's grades from a first exam according to the details of the problem. And again, that's just where I have space to write it, so that's where it's getting written today. It's not where it's written on my paper at all, actually. So. All right. So this is stem and leaf plot. Sort of piggybacking onto that, we have something called a back-to-back stem and leaf plot. These are actually two stem and leaf plots combined, and they're done in such a way to show two sets of data by comparison. One will actually have the leaves to the right, just like we did it, and then one of them is going to have the leaves over to the left. So, this is the data from my second exam. And you have space, a lot of space, I know, at the bottom of this paper, but you need the space to be divvied up well because we're going to draw multiple stem and leaf plots. So my suggestion is to leave the bottom part blank for the moment, and let's just draw a little stem and leaf plot in this right-hand side, okay? Because you're going to need this bottom part to put all of it together, and right now we need just the new data's information that I'm going to write to the side. So I don't have the same imagery space-wise on my screen, but I'm just going to flip over to here, and I'm going to draw my original new data right here. And I'll use the data that's written down on my screen or my paper. So as you're taking a look at this data, what is your smallest value? What is your largest value? 99. 64. Yeah, 64 is actually on there. So 60s to 90s, right? So there's no 40s and 50s. I mean, like, that's already kind of nice to see happening. So over here, I'm going to draw a stem and leaf plot, the first sort of sketchy one that I was doing before, but I only need the data to go from 6, 7, 8, and 9. And we're going to write it in. So over here, we have 93, 96. And then I have 98 and 66, 67 and 82, 92 and 85, 64 and 81, 86 and 72, 96 and 95, 99 and 95, 94 and 74. This test went better, didn't it? It did. Okay, so what we're going to do on where you've got the larger space at the bottom of your screen is we're going to actually create the stem and leaf plot that's back to back. So you're going to have a column in the middle that's got all the stems on them. Now, our first stem and leaf plot went from the 40s to the 90s. Our second one only goes from the 60s to the 90s, but I need both data to be able to represent it, so I still need to go from the 40s to the 90s. So my stems will be 4, 5, 6, 7, 8, and 9, just like that. We are going to take our new set of data and work with it first, and we're going to make that on the right-hand side. There's not necessarily a reason why, except that to me it makes sense that if you're comparing two sets of data, you'd put the first data on the left and the second data on the right. The first data represented my first exam, the second data represented my second exam, so it sort of seems reasonable the way we read for that to be our ordering. So over here, our new data, I have 66, 67, and 64. So 4, and then 6 and 7. So over here, I have 4, 6, 7. And then I have 2 and 4, lined up, of course, 2, 4. 2, 5, 1, and 6. So I go 1, 2, 5, and 6. 1, 2, 5, 6. And then the 90s is really long. We'll probably do it in a couple of steps. Let's see, I have a 2, 3, 4. So 2, 3, 4. 5, 5, 6, 6. 5, 5, 6, 6. And then 8, 9. Okay, everybody good so far? All right. Now, the data that we got from the previous problem, example 3, is further up on your sheet, and we're just going to flip the diagram around. So we had a stem that was 4 and a leaf that was 3, and we're just going to write the leaf on the left now instead. So that's going to look like that. It's not exactly mirror image, but the data itself is switching places, right? Then you had a 3 and an 8, so we're going to do a 3 closest here and an 8 further out. So we're reversing the order. We had 67. And then we had 2 4s, 4, 4, and then 6 and 7. The 80s are 0, 2, 7, 7, and then 8, 9. And the 90s are 0, 0, 4, and 4. So again, we need the key that said the same thing as we did before, where we have, it looks a little different now, so let's just use that same 40. The 4 and the 3 is a score of 43, but we also have the other side of it, right? So like a 6 and a 4, like this, those vertical bars there, is a score of 64. So just trying to give the reader some kind of an idea of what they're looking at. If I put the double bars around it, then I know I'm talking about the leaf in the middle between those 2 double bars. And a title. So our title, I have space on my left, so I'm going to do that, is that this is the first and second exam comparison. That's what we're doing. We're trying to compare the first and second exams. Okay. I think we have time for one more, so we'll do one more type of a table. Okay, any questions on that one before I flip my screen? Brooke.
So just to clarify, you can put like both the title and the like scoring stuff wherever on
Yeah,
these ones?
it doesn't matter where they go. Mm-hmm. If you're labeling something specific, which we will be next class period, we won't get to it today, there are some locational kinds of things that make sense to do, and not putting it there wouldn't make any sense, but here it doesn't have any sort of location that's better or worse than any other, really. All right, a grouped frequency table is very useful. It shows how many times data occurs in a range of classes or intervals. So people do this kind of counting all the time. In fact, if you were to go out right now and you were to look at the COVID data, they've put people into age categories, and they tell you how many people have died or have contracted the disease in certain age categories. That's what they're doing. They're making classes of ages. And there's probably reasons as to why you would choose certain categories over others. I don't know what the reasons are for the categories they've chosen with this current situation. But it makes sense for us when we're talking about the data on example 5 that the grade categories would represent the scores that we would consider as an A, B, C, D kind of range. So there's often a natural breaking up of things. And in fact, there must be a natural breaking things up in terms of ages too. Have you guys ever done surveys where they put age categories and they say, you know, I want you to select the age category in for a survey? They're always the same age categories. It doesn't matter if you go to Subway or if you go to Panda Express. They use the same age categories. So there's got to be a reason they're doing that, but I don't necessarily know what it is. So with our grade categories here, this is our data that we had just a moment ago from our second exam. And it makes sense to us to put the 60s in a category, and the 70s in a category, and the 80s in a category, and the 90s in a category, right? I mean, like that's kind of why we chose those as our stems, right? They make sense to us. And they make sense to us for a grouped frequency as well. So we're going to draw our table, and our table will include 3 columns. The first column is the grade column, right? And it's kind of giving the categories. Our categories go from 60 to 69, 70 to 79, 80 to 89, and 90 to 99. They should be equally spaced. If we have a 100 in here, it kind of actually throws things off, to be honest. But they should be equally spaced. Every single one of these actually encompasses 10 different graded values. If you count from 60 up to 69, there's 10 different grades in each category. So they should be equally spaced for this to make sense. You're also going to have a column that we're just going to call the tally column. So in our tally column, what we're going to do is we're just going to make a hash mark, a tally mark for every grade that goes in that category. So for example, when I have 90 and 96, I make a hash mark for 90 and a hash mark for 96, or 93 and 96. I have 98 and 66, so I make a hash mark in the 90s column and a hash mark in the 60s column. I have 67 and 82, so that's a 60s and that's a 70s. 85 and 92, that's an 80s and a 90s. 81 and 84, an 80s and a 60s. 72 and 86, a 70s and an 80s. 95 and 96, we'll actually cross-hatch it when we get to the 5s. It's easier for us to count that way and one more. 95 and 99, 2 more of them in the 90s column. And then 70 and 90s, 70s and 90s. So our tallies look something like that. The reason there's a tally column is because the tally column is really quick to do. You can just plop them all in there really quickly. You don't lose track of your data. The most important column is actually, well, I don't say it's the most important, but it's very important, is the next column. It's called the frequency column. Some people like to skip the tally column and go straight to the frequency column, and they like to count. For example, if you were just doing the frequency column and you decided you weren't doing a tally column, I'm not telling you you should, I'm just telling you what error would happen, is that it's very likely as you went through and you started counting these that you might miss something. You might forget one of them, right? It's actually really likely, especially if your data set's rather large, and it quite likely could be. So it's much easier to look at the tally column and just count. Hey, look, I got 3 hash marks. Lots easier to count those 3 hash marks or tally marks than it is to actually look for all the 60s in my data set and count them. And then I have 3 70s, I have 3 80s, and did I mess one up?
Yeah, I think there's like supposed to be 2 70s.
Okay, I was like, I know I messed one up because that's not the way my data set did it. Sorry. So sorry. Not being careful. So there was 2 actually here, there's 4 here, and then 9. Yeah, that's what I have on my paper. Sorry, guys. Okay, there's no keys needed on this one. All the data is very straightforward. It's got column headers, if you will. That's kind of like having keys, right? You're giving data sort of some context. The only thing that we're missing and that we still need is actually a title for this. And the title looks kind of like the titles we've done on the last 2 where we've been talking about grades. So this is actually the grades from a second exam. And that's it. So this is a histogram, or this is a grouped frequency table. Next time we'll be doing histograms. That's our next one. All right, so there's no homework that you have to do tonight, which means tonight would be a great night to do redos. Absolutely. I'll look forward to getting those from you guys next time, or sliding them under my door tomorrow if you have them done sooner. That'll be great too. Have a great evening.